Okay, we're back again after the dog. Right, so multiplying this out, 2ct. Okay, so what are we doing? We're trying to find values of c and t that these are equal for all values of t. What you can do is like Laplace, you can substitute in values of c and generate equations in c and d. That's absolutely fine. That's however you do it, it doesn't really matter. But probably the way that I'd possibly recommend is more like when you're completing the square, when you're comparing the coefficients. So let's look at the coefficients. How many t's have we got on the left? We've got 2c times t. And what constants have we got? We've got 3c plus 2d. And we're trying to force this equal to 2t. So we compare the coefficients. So on the left, you've got 2c times t, and that 2c must equal 2. So no big mystery about what c is going to be. So I want 2c to equal 2, divide both sides by 2, c must equal 1. If c is equal to 1, there's a chance. Now can you deal with the rest of it? Now you have to have a little think. This is the constant term over here. And the question is, what's the constant over here? Well, it's 0. So you want this to equal 0. 3c plus 2d to equal 0. But of course you know that c is equal to 1. So that means that 3c is 3. Take that away from both sides. We've got 2d is equal to minus 3. I'm okay, am I? Yeah. And then divide both sides by 2. D is equal to minus 3 over 2. So if c is equal to 1 and d is equal to minus 3 over 2, ct plus d is a solution. So this is what's called a particular solution. Particular solution, c is equal to 1 and d is equal to minus 3 over 2. Okay. Everything working out there? Yeah, everything looks good. Okay, now we add together, like the last time, the homogeneous and the particular, and that's what the general solution is. So the general solution is the homogeneous, which is a times e to the minus t plus b times e to the minus 2t plus the particular plus t minus 3 over 2. And this can satisfy, this general solution, all possible initial conditions, and this is everything we set up to here. But now in this question, for one extra mark, which is a little scanty, but there you go, you have to find the a and the b. In other words, initial conditions are given. So the initial conditions are x of 0 is equal to 0, and the other initial condition is that x dashed of 0 is equal to 0. And both of them should give us equations in a and b. Sometimes individually they might give us a or b. Just going to zoom out a bit there. Right. So we'll apply the first one. This says when t is equal to 0, x equals 0. So substitute t equals 0 to this. So this says a. I'll go a little bit quicker here. Oh, no, I won't. Okay, if I substitute 0 into this, it's minus 0. So e to the minus 0 is e to the 0, and e to the 0 is 1. So this is a times 1. Plus, similar story, if you substitute in t equals 0 into this, you have e to the minus 2 times 0, which is e to the 0, which is equal to 1. This just gives you 0. If you sub it in. And the minus 3 over 2 is just sitting there. And this, when you substitute in this t equals 0, you must get x equals 0. So this is what is written here, the a times 1 plus b times 1 plus 0 minus 3 over 2 is equal to the general solution at t equals 0, and it must equal 0. So you get an equation here, a plus b, add this to both sides, a plus b is equal to 3 over 2. Okay. And now apply the other initial condition. So we need to be able to differentiate this. If you have any issue with the differentiating, the Numbus e-learning thing I spoke about has lots of practice for this. So we need to differentiate the general solution. Okay. Now it's not the hardest differentiation in the world. I would go over the tool if this is any bit difficult. So we'll just sort down here. You've got a constant times a function, fix the constant, and the derivative e to the minus t is like derivative e to the minus 1x. It's minus 1 e to the minus t, plus fix the b here, and the derivative of e to the minus 2t is minus 2 e to the minus 2t. It's in the tables. And the derivative of t is 1, and the derivative of a constant minus 3 over 2 is 0. So this is the derivative of the general solution. Let's tidy this up. This is minus a e to the minus t minus 2b times e to the minus 2t plus 1. And we know that this evaluated at 0 is equal to 0. So the initial velocity is 0. So therefore, the general solution evaluated at 0 is equal to minus a. Now substitute in 0 into an exponential, you get out 1. Minus 2b, substitute 0 into an exponential, you get 1. Plus 1, and we know that this must equal 0. So take away the 1 from both sides, or actually maybe add the a plus 2b to both sides. You get a plus 2b must be equal to 1. And what I'm going to do, so I've got two simultaneous equations in a and b, so this should be no problem. Write down minus this equation. Add these two equations together. A minus a is 0, 2b minus b is b, 1 minus 3 over 2 is minus half, so b must be minus a half. And then sub that into this. A plus b, a minus a half, is equal to 3 over 2. Add the half to both sides. 3 over 2 plus a half is 2. So we found that a is 2 and b is minus half. Now this will get you full marks, but it's probably worth presenting your answer properly. X of t now is equal to a, which is 2, e to the minus t, plus b, which is minus a half, e to the minus 2t, plus t minus 3 over 2. And then you can kind of, have I answered the question that's asked? Yes. Does my answer make sense? You can probably just check one of the initial conditions. If you substitute 0 into this, what do you get? Do you get 0? Yes, you do. And if you've time, you could do more. You could differentiate it, sub in 0. Did you definitely get 0? You could even go as extreme and taking this, differentiating, basically checking does this solve the original differential equation. That's probably overkill, but there we go. So that would be a fairly tough 40% test, but I'll be here to support your learning all the way.